In this video, I am explaining TTL logic. TTL logic means transistor logic. So in this TTL logic, there will be the three different configuration. First one is open collector output. Second one, totem pole output. Third one is tri-state output, or we can say three-state output. First, we are going to see about the open collector output. In this open collector output, this is the open collector output. So in this open collector output, the multi-emitter transistor is used. Here multi-emitter in the sense here, so this is the transistor Q1. So here base and collector terminal is single terminal, but emitter is multi-terminal. That is multi-terminal transistor is used. Instead of using multiple transistor, we are using multi-emitter transistor we are using. So in this TTL logic, input given to the emitter terminal. So this is the emitter terminal of the transistor Q1. This is the base terminal of the transistor Q1. This is the collector terminal of the transistor Q1. So this is the base of transistor Q2. This is collector terminal. This is emitter terminal. So this is base of transistor Q3. This is collector terminal. This is the emitter terminal of the transistor Q3. So collector terminal of the transistor Q3 is nothing but output terminal Y. So now you see the multi-emitters in transistor Q1 are connected to the inputs. The two voltage levels are 0.2 volt for low level, 2.4 to 5 volt for high level. There are two voltage levels. One is nothing but low level voltage. Another one is nothing but high voltage level. Low voltage level is nothing but 0.2 volt. High voltage level is nothing but 2.4 to 5 volt. So in digital we are saying on and off. That is we are giving logic 0 and 1. Logic 0 in the sense low voltage. Logic 1 in the sense high voltage. So low voltage level is nothing but 0.2 volt. High voltage level is nothing but 2.4 to 5 volt for high voltage level. So this is the this circuit is the NAND gate circuit. If any input is low, the corresponding base emitter junction of transistor Q1 is forward biased. The voltage at the base of transistor Q1 is equal to the input voltage of input voltage of 0.2 volt plus VBE drop. So VBE drop is nothing but either 0.7 or 0.9 volt. In order for transistor Q3 to start conducting, the path from Q1 to Q3 must overcome the potential of one diode drop in the base collector junction of transistor Q1 and two VBE drops. That is nothing but VBE drop of Q2 and VBE drop of Q3. So here 3 into 0.6, it will be 1.8. That means here we are giving the this is the multi-emitter transistor. So here in this is when this transistor, when this PN junction becomes forward bias, when we are giving low input to the emitter terminal, because this is the NPN transistor. So emitter terminal is N type. So when you are giving low input to the emitter terminal of the transistor Q1, the corresponding PN junction becomes forward biased. So when it is on, what will happen? The transistor Q1 becomes, okay, when this PN junction is forward biased, transistor Q1 is on. So when it is on, what is the base voltage of transistor Q1, which is nothing but 0.2 plus 0.7, it will be 0.9 volt, it will be present. So here to turn on this transistor Q3, so which requires the base collector junction potential plus base emitter voltage of transistor Q2 plus base emitter voltage of transistor Q3. So to turn on this transistor Q3, which requires 0.6 plus 0.6 plus 0.6. That means to turn on transistor Q3, which requires 1.8 volt. So if all the inputs are low, what will happen? The transistor Q1 becomes on. So when it is on, what will happen? This potential becomes 0.9 volt. So here when it is on, here this voltage will be 0.9 volt. So when it is on, what is the collector voltage? It will be low. So when this potential is low, what will happen? Transistor Q2 and Q3 becomes off, because when to turn on transistor Q3, which requires 1.8 volt. But when transistor Q1 is on, the base of transistor Q1 becomes 0.9 volt. This voltage is not enough to turn on transistor Q3. So transistor Q3 is off. So when it is off, the corresponding output voltage will be high. That is nothing but open circuit voltage. So by connecting the external resistor, we can get the high output voltage we are getting. So if any one of the input is high, or all the inputs are high, what will happen? If any one of the input is high, or all the is like, yes, now we are going to see about if all the inputs are high, what will happen? We are going to see if all the inputs are high, what will happen? All the base emitter junction becomes reverse bias, so transistor Q1 is off. So when it is off, the transistor Q2 becomes on, because when it is off, here potential will be open circuit voltage. So this voltage is high. So that voltage is more than enough to turn on transistor Q3. So transistor Q3 is on. When it is on, output will be when it is on, output will be low. That is when all the inputs are high. So you see here, if any one of the transistor is low, if any one of the input of the transistor is low, if any one of the input of the transistor is low, what will happen? The corresponding transistor becomes on. So when it is on, what will happen? The base emitter current flows through that path. The current flows through that path. So the base voltage will be 0.9 volts. So that 0.9 volt is not enough to turn on transistor Q3. So transistor Q3 is off. So output will be high. So you see here, this is the multi-emitter, but the base terminal of all the transistors are connected together. Then collector terminal of the all the transistors, that is collector terminal is common, base terminal is common. Only emitter terminal is different. So if any one of the input is low, or all the inputs are low, what will happen? The corresponding transistor, that means the corresponding base emitter junction becomes forward biased. So transistor Q1 will be on. So when it is on, the base voltage of transistor Q1 becomes 0.9 volt. So this 0.9 volt is not enough to turn on transistor Q3. So transistor Q3 is off, because to turn on transistor Q3, which requires 1.8 volt. So transistor Q3 is off, so corresponding output voltage will be high. If all the inputs are high, what will happen? All the inputs are high, transistor Q1 becomes off. When it is off, that voltage becomes open circuit voltage. So transistor Q3 is on now. When it is on, the corresponding output voltage will be low. So from this circuit, we are getting the NAND output. This is nothing but open collector TTL gate. Next one is nothing but we are going to see about the totem pole output. So in this totem pole output, the TTL gate with the totem pole output is same as the open collector, except for the output transistor Q4 and the diode D1 when the output Y is in low state. When the output Y is in low state, transistor Q2 and Q3 are driven into saturation in the open collector state. So here in this open collector state, that is when output Y in low state, Q2, Q3 driven into saturation in the open collector state. Okay. So here for that, then when output Y is high, that transistor Q3 becomes open circuit. Okay. From by connecting the external resistance, we are getting the high voltage. So here just the modification of open collector circuit is nothing but totem pole output circuit. So here we are externally we are connecting diode D1 and transistor Q4. So here the voltage in the collector of transistor Q2 is nothing but VBE of the transistor Q3 plus VCE2 of transistor Q2, which is nothing but 0.9 volt. Here now this is nothing but we can say as the totem pole TTL gate. So here the same circuit which is like the open circuit, except open collector, the same circuit which is like the open collector output, but here except diode D1 and transistor Q4. So here transistor Q4 and diode D1 is connected to get the output. That means when Q3 is off, Q1 must be on. When Q4 is on, Q3 must be off. When Q4 is off, Q3 must be on. Okay. For that, we are connecting this diode D1 and Q4. So you see here, this is the multi-emitter, the same concept here. If any one of the input is low, what will happen? The corresponding transistor Q1 is on. When it is on, what will happen? This base voltage is 0.9 volt. So this voltage is not enough to turn on transistor Q2 and Q3. So transistor Q2 and Q3 is off. When it is off, the output voltage will be high because that output, the circuit output taken from the collector term of the transistor Q3. So here, when it is off, what will happen about the transistor base of transistor Q4? So here, base of transistor Q4 will be 0. Here, when Q2 is off, what will happen? Here, this potential is nothing but here, what is the potential? Here this is off, here this is off. So here you are getting the open circuit voltage. So Q4 is on. So when it is on, here this diode becomes forward bias. Here current flows this path. It is coming like this. If all the inputs are high, what will happen? Transistor Q1 is off. So transistor Q2 and Q3 is on. So when it is on, what will happen? The output voltage will be low. So when Q3 is on, we have to check whether it is possible to turn on transistor Q4 or not. So here for that, you see when Q2 is on, so what is the base voltage of transistor Q4? So here when it is on, the base emitter voltage of transistor Q2 is nothing but 0.7 volt. Then here that collector, this collector emitter voltage of transistor Q2 is nothing but 0.2. So here what is the potential at this point? It will be 0.9 volt. It will be 0.9 volt. When Q3 is on, here potential is nothing but 0.9. So without this diode, what will happen? Transistor Q4 also on. But by connect here, we are connecting diode series with transistor Q4. So to turn on this transistor Q4, which requires 1.4 volt. But what is the voltage present here? Here voltage is nothing but 0.9 volt. So this voltage is not enough to turn on transistor Q4. So when Q3 is on, Q4 will be off. So from this, we are getting the NAND output. So this is nothing but totem volt TTL output. Thank you.